All right, guys, here we are, video 3 of 4. This is about finding the domain and range of a function. Domain and range. So first of all, the domain. The domain of a function is simply the set of values that we're allowed to plug into the function. So all the x values. X again here is quotes because that's the convention. But like I said before, you could go against convention and use a different letter if you really wanted to. Earlier, we called the set of all those x values big X. So notice the difference here. This capital X represents the set of all the little x values. When you're given an equation and trying to figure out what's in the domain, it's pretty much going to be all numbers. And if it's all numbers, we represent that in interval notation by saying, okay, you go all the way to negative infinity and all the way up to positive infinity. And then since you can never actually reach infinity, we use the open brackets. Open brackets mean you don't include those endpoints, as opposed to closed brackets, which means you do. So if you have finite numbers, something like -5 to 6, and you do include the endpoints, you can put the closed brackets. Closed brackets are just these more angular ones, right? Open ones are the ones that are like your typical parentheses. So if let's say you don't want to include the 6, then you use open bracket. So that's a quick review of interval notation too, for free. Now that's typically what it would be, except when there's instances when you're dividing by 0, so you want to exclude those points from your domain, or if you're taking a negative square root. Those are like the main things that we look for. Anything of that nature, or anything else that makes it undefined. There might be some other things that make it undefined that I'm not thinking about right now. Those are the main culprits, though, that take you away from the domain. They'll take those values out of the domain. Now, the range of a function. Oh, I like this color combination, blue and orange. The range of a function is the set of values that are possible outcomes. In other words, all the y values. Again, we're going with convention here, using y. When you plug in an x value that's in the domain, to be more specific, we call those the set of all those little y values capital Y. That's what we called it earlier, anyways, in the page up here. You remember that up here? Here, wrong. Hide the wrong area. Okay, so how do you determine what the range is? This one's a little more ambiguous about the exact procedure. When you're given an equation trying to figure out what's in the range, it helps to first solve for y. So that part is pretty straightforward routine. Computer easily do that. Then look closely at the domain and see what happens to y for values in the domain. So you want to try to find how big or how small is the y going to get. In particular, check any endpoints that are in the domain, like any boundaries within the domain. Check those points if they're going to be important values, maybe. Try to look for any maximum or minimum values. And just try to determine, looking at your function, what are the possible y values that could pop out based on what the possible x values are. All right, let's try the remaining problem. Not remaining, but let's try problems 9 through 15 now. And so you'll hopefully get a better feel for it as I explain it to you. Well, I just realized I copied the wrong portion earlier. We're starting with these guys. So not this ones yet. Okay, so for a question, the first few questions, 9, 10, 11, we're only doing domain. Domain is the easier one to figure out anyway. Range is a little harder, so right now, as we stand in this class, we're a little more limited to which types of functions we're going to check the range for. But these, we're going to check the domain. So domain, remember. Okay, starting out, let's look at 9. So 9 right here. What I'm going to do, I'm just going to do it here and then I'll erase after I'm finished. You can always rewind the video to make it reappear. So number 9, here's my function, right? I want to know the domain. To start with, it's any x value, except now look, what are the possible things that could go wrong? Well, here I have something in the denominator. So whenever x is 0, or whenever this denominator is 0, that's going to be outside of the domain. So x, in other words, cannot be 5 because the square root of x minus 5, or if x was 5, would be 5 minus 5, which is 0. And if that's the case, that means f of 5 is going to be 1 over 0, which is undefined. Okay, so that means x cannot be 5. That's outside of my domain. Now, what else could go wrong here? Well, looking at this thing, if I have a negative square root, that would also make things go haywire. So here, what would make this square root negative? So in other words, when would this inside part be negative? That's what I want to check, right? So I got to solve that inequality. I want to know, when is x minus 5? When is it less than 0? Okay, when is it less than 0? Well, solve that thing, add 5 to both sides. That means x is less than 5. Anytime x is less than 5, then I'm in bad shape because I have a negative square root, right? So if x is less than 5, then I'm undefined. I should say more specifically, f of x is undefined. Okay, so I kind of found the domain in reverse here. I found what x could not be, right? So x cannot be less, it cannot be equal to 5, and it cannot be less than 5. So what can it be then? So the domain is we got to state the domain in the positive sense, right? X cannot be 5, it cannot be less than 5 either. That means x could be anything that's greater than or equal to 5. As long as you're greater than or equal to 5, then you're fine. You're in the domain. Now, in interval notation, how do we represent this? So this is the correct answer, but we typically answer in interval notation. Like if you follow the online homework, it's all in interval notation. So to include 5, oh, wait a minute, I'm sorry. I made a mistake, guys. We said earlier, x couldn't be 5, right? So here, I got to make sure that I also take out that part. X has to be greater than 5. It cannot be less than 5, and it cannot be 5 either. So it's got to be bigger than 5. Okay, so that means I don't use a close bracket. I got to use an open bracket. I don't want it to be 5. Got to be bigger than 5. And anything bigger than 5 is okay. So I'm going to go all the way up to infinity. And remember, infinity always is accompanied by an open bracket because you cannot include infinity. Infinity is not actually a number. It's a concept. So there we go. Domain is this guy right here that I'm about to highlight in black, which is when you turn it to highlighter, actually gray. So 5, comma, infinity, open bracket at both ends. That's the answer for number 9. All right. I'm going to clear this little sketch pad here. Oops. Oh, okay. I don't know if it's going to work. That did not work. And I'm all messed up. Oh my gosh. Okay, there we go. Okay, guys, I got to do it. I can't be lazy. I got to just actually use my eraser here. Just trying to do it all in one crack. The good news is that the sound of this pen hitting the pad is somewhat pleasant, isn't it? Okay, number 10. Domain for this guy. Okay, so 10 here. Let me just write the function down again. Square root of x minus 3 over x minus 5. First thing that could go wrong is when the denominator is 0. And that happens when x is 5, so x cannot be 5, right? I'm not going to go through all the algebra here, but 5 minus 5 is 0. And this is the denominator, right? So x cannot be 5. What about the top? Okay, well, I have the square root of x minus 3. And this one's, it cannot be less than... as I'm writing, I'm thinking maybe I should do this in the positive sense. I'm going to stick to the same. So it cannot be less than 0, right? I'm sorry. I mean, x minus 3 cannot be less than 0. Or I have a square root of a negative. So that means x cannot be less than 3. So this would be outside of my domain. Okay, so what is in my domain then? Well, as long as I'm not less than 3, right? So that means any x that is greater than or equal to 3 is okay. and as long as x is not equal to 5. Right? This is essentially my domain. Okay, but how do I write that in interval notation now? Well, I'm going to start from 3, right? This time it can be equal to 3. If I'm equal to 3, I'm going to get 0 on the top. That's fine. So 3 is okay. I'm going to go all the way up until I hit 5. Once I get to 5, I don't want 5. So I'm going to have an open bracket. And then I'm going to say either a union or an or you can say or you can say the union. They mean the same thing. And I'm going to start not from 5, but don't include 5. And then go anywhere past 5, so up to infinity. Okay, so that's it right there in interval notation. That's number 10. Done. Okay. All right, moving on to number 11 now. This is 11. F of x is the square root of x squared minus x minus 6. Okay, no fractions to worry about here. So I'm not dividing by 0. Only thing I have to check is when is this thing possibly going to be negative, right? So x squared minus x minus 6. And you know, earlier I was kind of hesitating which one to do. That's because you can think of this as two ways. So up until now, I've been looking at what is not in the domain. If you want to, you can solve in the positive direction instead and say what is in the domain. And so what is in the domain is anything as long as this inside portion is bigger than or equal to 0. Right? So this is in the domain. And earlier I was finding out what's out of the domain. And then trying to find everything else, right? So if I'm less than 0, that's out of the domain. If I'm bigger than or equal to 0, that's in the domain. So you just pick one or the other to solve. I'm gonna go with in the domain this time. I think it's more direct. So let's leave this one on the side for now. This is just side note. I'm gonna focus on what's in the domain and solve this equation. So how do I solve this? You know, you got a quadratic. You got 0 on one side. It's kind of all set up already. Just gotta make sure I factor this thing if possible. And this one's an easy factorable one because it's 6. And 6 is the product of 2 and 3. And 2 minus 3 is negative x. So I have x minus 3 and x plus 2. This is the factor form of that, right? And if you want to double check, do some work on the side. X times x is x squared. X times positive 2 is plus 2x. X times negative 3 over there is negative 3x. And negative 3 times positive 2 is minus 6. So I get x squared minus x minus 6. Okay, so that matches what it was supposed to be, right? Okay, so that side work done. Just double checking that I factored correctly. Okay, so if that's the case, then okay, when is it equal to 0? Equal to 0 at 3 and let me write it like this. X squared minus x minus 6 equal to 0 with x equal to 3 or negative 2. Okay? So I'm going to check this. I'm going to kind of just sketch out my number line here. If it's negative 2, if it's positive 3, that's when my function is 0, right? This not function, but this expression here is going to be 0. So I don't know when it's going to be positive. Well, let's look at the left side. Here I'm checking x squared minus x minus 6. Or another way to look at that is to say x minus 3 times x plus 2. Okay, well, if I'm to the left of negative 2 over here somewhere, then this guy is going to be negative something minus 3. That's going to be negative. And it's going to be something, x is going to be something big negative, like negative 3 plus 2, for example. Actually, you know, let me just put a point. That's the easiest way to check. If I put negative 3 here, this is going to be negative 3 plus 2. That's going to be negative. And here, negative 3 minus 3, that's also negative. So negative times negatives makes a positive. Okay, what's in between negative 2 and positive 3? The number 0 is. So if I plug in 0 here, 0 minus 3 is negative. 0 plus 2 is positive. Positive times a negative makes a negative. Or I should say negative times a positive makes a negative. Now if I go past here to say like 4, 4 minus 3 is positive. 4 plus 2 is positive. Positive times a positive makes a positive. So I'm positive to the left, positive to the right. Now, what was my original question? I was trying to find things in the domain where it's bigger than 0, right? So that means as long as this thing is bigger than 0, I'm in the domain. So that's to the left of this here in that direction, and then to the right in that direction. So all that to say, what's my domain now? Domain is going to be in interval notation to the left of -2. And this time I include -2 because I can take a square root of this if it's 0, right? And -2 makes the whole thing 0. And or union when I go from 3 onwards to infinity. Again, open use of parentheses if you're talking about infinity. So there's the domain. Okay, that's 11. Okay, now we got 4 more. And okay, I know it sounds like a lot, but I think for the most part, these are a little easier. Except for this one's kind of the same as something we did earlier. I'm going to do the same thing, one at a time, starting with question 12. And here right away, I see a line, right? This is the equation for a line. So already I know, super easy. It's going to be -infinity to +infinity because the line goes up and down forever, left and right forever. Right? You can go as high as you want, as low as you want, as far left as we want, as far right as I want. How do I confirm this? Well, there's no restrictions on the domain, first of all, right? There's no square roots of a negative. There's nothing that I can't put in as x. So domain for sure, -infinity to +infinity. Now, if I plug in something that gets really big, like going towards -infinity, for instance, this is going to be a really big negative number, and there's no cap on that. So range also -infinity. If I get something really big positive, it's going to be 3 times something really big. It's going to get really big. -2 is still going to be really big. It's going to go onwards towards infinity. It also helps maybe to visualize it by sketching it. Here's -2 is the intercept. 3 is the slope. So you got a line that looks like this, right? So I can continue this line on forever as far as I want. And it's going to encompass any x value to the right. I could continue this line as far as I want to the left. That was not accurate in this direction, right? That's going to encompass any x value to the left. It goes as far high as I want or as far down as I want. And there's no breaks in it, so I get every single value. So all that matches what I said about the domain and range. It's -infinity to +infinity, everything. Okay, not so bad. 13 now. Okay, first of all, what's the domain? And there's no restrictions again, right? There's no dividing by 0. There's no square roots of negatives. So the domain, again, is going to be -infinity to +infinity. Now, in this case, you have a parabola, right? This is our good old friend, parabola. So again, it helps to visualize what's happening here. I'm going to start with the picture this time. Intercept at 4. Otherwise, it's x squared. So it's just x squared plus 4, right? It's going up like this. So if you look at it, it keeps going up forever. That means any y value as high as I want is going to be included. But it doesn't go past this point of 4. Now, thinking back to my original values, right? What's the smallest thing that could possibly end up here? If you put it x as 0, it's 0 plus 4 is 4. So y could be 4. But if I put x as something negative, like -1, this is going to be -1 squared. It's going to end up being 5, right? Okay, let me write what I'm telling you in a table. So if x is 0, y is going to be, this is y being f of x, y is going to be 0 plus 4 equals to 4. Okay? If x is -1, this is x squared, that's going to be +1, plus 4 is going to be 5. If x is +1, it's going to be still 5 because it's 1 squared 1 plus 4 is 5. So it's going to be only increasing, right? The smallest value it could get is 4. That's the smallest y value. So that means the range is going to go from that 4 onwards forever upwards. From 4 all the way to infinity. There it is. That's 13. Okay. 2 more in this video. And, you know, try not to keep these things too long. I think the last video shouldn't be too bad. The last one, you're just looking at the graphs. But I shouldn't promise anything because, you know, this general principle of life, things take longer than you expect them to. Okay, number 14. Yeah, fx equals square root of 49 minus x squared. We kind of did something similar to this, right? Earlier, we had a square root, a couple square roots, and we had to figure out the domain from there. So I'm not going to go into super great detail here. But enough suffice to say that x, it's going to be, this inside thing is going to be 0 when x is equal to 7 or negative 7, right? So those are things that are going to make this square root 0. Now, anything beyond 7 or negative 7, this is going to be subtracting something that's bigger than 49, which makes this a negative square root. Square root of a negative, which makes it outside the domain. So what is in the domain then? Well, the smallest you could be is negative 7. The biggest you can be is positive 7. You can be 7 itself, which is why I have the brackets, because then you just get 0, right? So it's negative 7 to positive 7. That's the domain. Okay, what about the range? What happens if I put in exactly 7? If I put in exactly 7 or negative 7, this ends up being 0, right? So it's going to be 0. What if I plug in 0? X is 0. Then I'm going to get the square root of 49 minus 0, which is 7. So let me write what I'm telling you in a table here. If I plug in negative 7, this is going to be negative 49 minus 49 is 0. If I plug in positive 7, same thing, I get 0. If I plug in 0, it's the square root of 49, which is 7. So think about the graph now. I've got negative 1, 2, 3, 4, 5, 6, 7, 0. I've got positive 1, 2, 3, 4, 5, 6, 7, 0. And then I've got 0, 1, 2, 3, 4, 5, 6, 7. So here we go. And it turns out to be just kind of like this circle shape here, half circle, right? Oh, we kind of saw this, right? Before with semicircles, we saw equations for semicircles. Here, the biggest value of y is 7. And then the smallest value here is y. 0, I mean. This is 7, 0. This is 0, 7. So the range is going to be, well, you can hit 0, it's possible. You can hit 7, it's possible. And everything in between that, you can't go higher or lower than that. Sweet. Okay. That's 14. One more. And we're out of here for this video anyway. Okay. Number 15 now. F of x equals to absolute value of x minus 6. Now what could x not be? That's kind of a weird question. What could x possibly be? X could be anything, right? There's nothing that's going to go wrong here. There's no negative square roots. There's no denominators that could be 0. So the domain is going to be all real numbers. We represent that by negative infinity to positive infinity. Again, open parentheses, yeah? Okay, now what about the range? I think it's, again, helpful to start from the picture here. Normally, absolute value of x looks like this, right? But if I subtract 6, it's going to go down by 6, 2, 3, 4, 5, 6. And then it's going to go up like that. That's the sketch of the picture. So looking at that, the lowest value is going to be negative 6. It's going to go up forever. Excuse me. So that means the range is going to be from negative 6 to infinity. Now, I made a mistake here because it can be negative 6, right? If x is 0, you get exactly negative 6. So include the negative 6. And then go upwards forever. And that's it, guys. That's it. All right. I'll see you in the last video.